Okay, hello again students. This is another Blue Pen tutorial and this time we're going to be looking at indices. I'm splitting this over two parts. The first part is usually what you find as grade B topics and we will go on to the higher grade A topics in the second part. So this video is just part one. Okay, so let's begin. Alright, so the way we're gonna look at this, the way we're gonna break this down is I'm gonna go over three different laws of indices. So you're probably given a bunch of these laws and you may be struggling with their application. So we're gonna go through the first basic three. The first one is as such. A to the power of 0 is 1. That means any number, whether it's 3, whether it's 5, whether it's 268, whether it's 72, anything raised to the power of 0. Please do not confuse this for a degrees sign, like 27 degrees, like an angle that would be like that big. Don't confuse this for degrees, okay? This is to the power of 0. To the power of 0. Let me just elongate it so it looks more like a 0. So, anything to the power of 0 is 1. This is not something you really need to look into detail. This is just something you need to remember. Anything to the power of 0 is 1. You just need to learn and remember that again. Okay, so let's go into the two laws that we will look at in detail and figure out how to apply. So the first one is multiplying. So we've got a to the power of m times a to the power of n. And that's a to the power of m plus n. So if you're not good with formulas and you're not good at remembering these things, this is how we're going to break it down. Now, the base numbers, so the numbers on the bottom, they have to be the same. They're not going to work if they're different, and I'm going to show you why. So let's give an example. Let's say we've got 5 to the power of 3, and we're going to multiply that by 5 to the power of 6. Okay? The indices, the index, tells you how many times you're multiplying that number by itself. So 5 to the power of 3 means you're multiplying 5 by itself 3 times. This is 5 to the power of 3, because there's 1, 2, 3 5s that you're multiplying by itself, okay? And we're multiplying all of this by 6 lots of 5s. So 1, 2, 3, 4, 5, 6. I just want to reiterate, when I say 6 lot of 5, I don't mean like 5 times 6 is 30, sorry. That's where people often make mistakes. These two numbers aren't multiplying by each other. This number on the top, the index, tells you how many times you multiply the base number by itself. So it means how many times this number is going to make an appearance. And in this case, it's 6 times. Okay? Now, 5 to the power of 3 times by 5 to the power of 6, let's see how many 5s we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, we have 5 to the power of 9. So that is why any number to the power of m times a to the power of n is a to the power of m plus n, because you are just adding together the instances in which you have the base number. So number 5 appears 3 times, and then the number 5 is going to appear 6 times. So altogether the number 5 will appear 9 times. Okay? Now, if we had 5 to the power of 3 times by 7 to the power of 6, well then that's not going to work. Because when we multiply that out, we get 5 times 5 times 5 times 7 times 7 times 7 times 7 times 7 times 7. When we try to add this together, that's not going to work because 5 still just appears 3 times and 7 just still appears 6 times. 35 doesn't appear any times. 57 doesn't appear. You can't bring together the number 5 and the number 7. So you can't do 5 times 7 is 35 because 35 doesn't appear any point in this expression. Okay? So that is how you come to this. So that is an understanding of this law of indices here, the addition. Now, it's a very similar case to the subtraction, and we're going to look at that now as well. So, the next one we have is a to the power of m divided by a to the power of n. And that's going to give us a to the power of m minus n. Now, we're going to go over, make these dots a bit bigger, we're going to go over why that is. So, first of all, I'm going to use indices. First of all, I'm going to use a fraction. Bear with me, don't worry. Now, if I've got a to the power of m divided by a to the power of n, the first thing you need to know is that any number divided by any number, let me break away from here for a second and give you the example of 6 divided by 3. Anything divided by anything else, we can write it as top divided by bottom, okay? If you don't like fractions, please do not let this put you off, okay? In the olden days, when they used to do their accounting and stuff like that, and they used to have the books where like, Johnny owes me 6 divided by 3, it was just easier to write column-wise. That's all this is. This is just writing a division in a column. That's all a fraction is. There's nothing to be scared of, okay? So, bearing that in mind, I'm just going to write this in the same column version as I did down here. Again, nothing to be frightened of. So I'm going to put this at the top and this at the bottom. In a lot of exams, you will usually see it asked in this format anyway. Still nothing to be afraid of. Now, let me give you an example. Let's have an example. So, let's say we have 4 to the power of 5 divided by 4 to the power of 2, or 4 squared. Okay? Now, first I'm going to write it in its column form as a fraction. So I'm going to put the first part of the division on top and the second part of the division on the bottom. It means exactly the same thing. Now, I'm going to write this out. So that means 4 times, remember, the index just tells you how many times you multiply the base by itself. So we've got 4 times 4 times 4 times 4 times 4. Now, on the bottom, we will have 4 times 4. Because it's 2, so we only multiply it twice. 4 only makes an appearance twice. Now we're going to cancel it down. So we're going to treat each thing as its own divisor. So this one is 4 divided by 4, which is 1. So we can cancel it out. That will just be 1. Here is another 4 divided by 4. We can cancel that out because that will just be 1. Anything times 1 is the same thing by itself. So we can just forget about the ones. Because 1 times 50 is 50. 1 times 1 times 4 times 4 times 4 is just the same as 4 times 4 times 4. So 1 times by anything is just that thing. So we're left with 1 times 1 times 4 times 4 times 4. Now, how many instances of 4s do you see? 4 appears 3 times. So that's going to be 4 to the power of 3. 4 to the power of 3 times 1 is still 4 to the power of 3. We times it by another 1, it's still 4 to the power of 3. So we can get rid of these ones. We can cancel it out. We can essentially ignore it. And so this is why, if we go back to the original thing, this is why it's taken away. Because 4 to the power of 5 divided by 4 to the power of 2 gave us the final answer of 4 to the power of 3. Thus, we just take it away. Because every time we pair up a number on the top and a number on the bottom, we take away one from it. So that means that all all of the smallest side, all of the bottom half, all of the denominator will be cancelled away. And what's just left is the remainder once we take away the bottom part from it. And so that is why this rule stands. A lot of these rules, if you're not good at remembering formulas, please don't sit in the exam and just give up. Go back to basic principles. Sit there and work it out, scratch by scratch. You can work it out. Okay? All right then. Well, this has been another Blue Pen Tutorials. Part 1, Law of Indices. Please stay tuned for Part 2, where we explore the A grade topics. Okay, thank you and take care.